absolute value equations. So first let's talk about what absolute value actually means. Absolute value of a number is the distance from 0 on a number line. That's all it is. It's just how far are you from the number line. So let's say if I want the absolute value of 3, it's just asking how far is 3 from the number line. It is 1, 2, 3 away. That's why it also works for negative numbers, right? So negative 2 is the value of negative 2. Negative 2 is over here. It is 1, 2 from 0. That's all absolute value is. It's just a distance. If you think about distance, if you ask somebody like how far is that 7-Eleven, they never go negative 5 miles. It's always a positive value. Distance is positive. That's why absolute value is always positive. Because of that, though, when we solve an absolute value equation, it should be up to 2 solutions because you get the negative version and the positive version. So, to understand the absolute value equation, the way we solve it is 1, we want to isolate the variable, isolate. And then 2, we're going to split the absolute value. We're going to do 1 negative and 1 positive. We'll talk a little bit more about that, and then we're just going to solve it. So after you split it, you just solve. So that's going to be the process. So let's do a few examples. So this first one here, right? So 7 equals absolute value of x plus 2. Step 1, get the absolute value by itself. So let's subtract the 2 from both sides. We have 5 equals absolute value of x. 5 equals absolute value of x. So once you get to the absolute value part, then here's where we're going to split it. We're going to say, well, usually we have the x on the left-hand side, so we're going to say x is equal to 5, or x is equal to negative 5. Well, really, if you're not changing this, what you're really changing is the number on the inside. Technically, what's really going on is we're doing x is equal to 5, or negative x is equal to 5. That's what we're really doing. But for a lot of times, it's easier to say, okay, we're going to split it. We're going to do x equals the positive version of this, and x equals the negative version. Because we're kind of skipping this step. This is what's really happening, right? The absolute value could be positive or negative. But most of the time, we just kind of skip that step. We just say, okay, x equals positive version of this, or x equals negative version of this. You kind of skip the dividing by negative 1 step. And there's our answer. X equals 5 or negative 5. Let's do another one. So we have this one right here, right? 2x minus 3 equals 1. It's already isolated on anything else, so next we're going to split it. We do 2x minus 3 equals 1. And we do 2x minus 3 equals negative 1. Now keep in mind, notice I kept this the same. I did not change this. The most common mistake I see is people always make that negative a positive for some reason. You're not changing this, right? You're changing this guy. We're kind of skipping that initial step where we divide by negative 1. So we have one side that's positive, and one side where the answer is negative. We're changing the answer. Then from here, you solve each one separately. So it just becomes 2 problems. So plus 3, 2x equals 4, divided by 2, x equals 2. Plus 3, remember the equal sign is a divider. 2x equals 2, divided by 2, x equals 1. This is an or statement. So x equals 2 or x equals 1. Okay, let's do a couple more. So now look at these. They have a number in front. So we're going to try to basically want to isolate the x plus 6. What's really going on here is pretty much just like, let's say we had this. Right? What's the process? Right? If I gave you this, the first thing you do is subtract 8 from both sides, and then you divide by 3, right? Same concept as this. We're going to minus 8 from both sides, then we're going to divide by 3 first. Once we get the absolute value alone, and then we're going to split it. So let's get rid of that. Same concept. Let's get the absolute value by itself. So we're going to minus 8. 3x plus 6 is equal to negative 3. And then we're going to divide by 3. Maybe you might see what's already happening. I have a negative 1. Remember what we talked about? Absolute value is always positive. You can't equal a negative number. This is no solution. Can't be negative. So again, the absolute value cannot be negative, so this is no solution. But I did have to isolate the absolute value first, right? I couldn't say that from here. I couldn't say that. I mean, kind of say that for that because it's 3. But you have to isolate the absolute value first before you could jump to that conclusion. So no solution on this one. Let's do this one. I think this one will have a solution. So same concept, let's try to get the absolute value by itself. So step 1, let's get rid of that 1 plus 1 plus 1, just like we're solving a normal problem. So 2, 3x plus 5 is equal to 10. And then we're going to divide both sides by 2. So you get 3x plus 5 is equal to 5. And then here we want to split it. So we're going to split this side, right? So 3x plus 5 is equal to 5. That's our positive version of the solution. Remember, we only change the solution. Remember, here we have 3x plus 5 is equal to negative 5. That's our negative version. And then we're just going to solve each one. So minus 5 minus 5, 3x equals 0. A lot of people freak out. Don't. It's a number. So now we divide by 3. I get 0 divided by 2, which is a 0. That's fine. You could get 0 as an answer. There's nothing wrong with that. Minus 5 minus 5. 3x equals negative 10. Divide by 3. And then we get x is equal to negative 10 over 3. So that's our answer. Right? A few more, then we'll do an actual application problem, and then we're done here. So this one here, same concept, right? Let's get the absolute value by itself. So minus 8 first, minus 8. 2x plus 1 is equal to negative 7. And hopefully now you see it. No solution, right? Can't be negative. Once you get the absolute value by itself, it can't be negative. I couldn't say that from before. If this was a negative, I can't say it yet, right? I have to get the absolute value by itself first. Can't be negative. No solution. This one over here. Let's get the x. So let's go plus 2 first. And we get 2 times 3x plus 1 equals 8. And we're going to divide both sides by 2. 3x plus 1. Absolute value 3x plus 1 equals 4. And again, now we have to split it. So you get the positive version, 3x plus 1 equals 4. And then you get the negative version, 3x plus 1 equals negative 4. And again, cannot stress enough, right? You're only changing the answer. That's it, right? This could equal 4 or equal negative 4. Either way, absolute value of that's going to be 4. So you're only changing the answer. Then from here, you solve it. So minus 1, 3x is equal to 3. Divide by 3, divide by 3. X is equal to 1. Minus 1, 3x is equal to negative 5. You're going to get a lot of fractions, so it's hard to make an absolute value problem work out perfectly. So you just deal with it. We get x equals negative 5/3. So that's the concept, right? So, right, the general idea is isolate the absolute value is what I was trying to say. So you want to isolate the absolute value. Once you do that, right, you split and solve. So you split it, you get a positive, and you get a negative. Again, do not change the inside, change the answer. Okay, last little thing here. Let's apply an absolute value. So the cruising speed for Kennedy's boat is 25 miles per hour. Oh, so relatable. Boat speed. Anyway, she plans to cruise at this speed for a distance of 80 miles plus or minus 10 miles. That's going to be our absolute value right there. The plus or minus 10 miles, right? The distance of 10 miles. That's going to be our absolute value. We'll get to it, but that's going to be key. As she is not sure the exact distance she needs to go. Write an equation that models the number of hours h that Kennedy would travel. So we need a formula for this, and our formula is going to be good old rate times time equals distance. Right, we're talking about distance, we have a rate, and we're trying to figure out the time. So our time here, hours, that's our time, so that we're going to put an h right there. So we're going to have this formula. Our rate is this guy, 25 miles per hour, so 25. And about 80 miles plus. So what's going to happen here is we're going at this speed, 25 miles per hour. We're not sure for how long, and we want to go 80 miles plus or minus 10. So plus or minus 10 is their absolute value. Right. So if we take our distance and we subtract 80 miles, we want it to be within a 10-mile range. That's kind of the way we do it. Like the absolute value is a plus or minus. It's like the range you want to find. So we want whatever distance we want to get to minus 80 miles, and we want that to be within 10 miles. So best way to do that is to an absolute value. And once we have that, we just solve it. Right? We know how to solve an absolute value now. It's already isolated, so all we gotta do is split it. So we're gonna do, at the positive one, where we just keep everything the way it is, 25h minus 80 equals 10. Then we do the negative one. Again, the negative one, we do not change the absolute value, we change the answer. So 25h minus 80 equals negative 10. and then we just solve each one. So we're going to go plus 80, 25h equals 90, divide by 25, divide by 25. H is going to be about 2.8. Feel free to use a calculator there. We're going to go plus 80. Is that 2.8? I think that might be 3.6. Sorry, look at the wrong number. Over here, plus 80, 25h is equal to 70. And then we divide by 25. So now this is the one. This is the 2.8 I was looking at in my notes. So 2.8. So we're going to have to go between, right? She's going to have to travel between 2.8 and 3.6 miles. So Kennedy will travel between 2.8 hours, I'll use it in hours, and 3.6 hours. There we go. That's the lesson.